Okay, welcome again. Today we will talk about these transceiver modules. Okay, these transceiver modules is very cheap module. You can use it to communicate and transfer the data to and from any embedded device like Arduino, Raspberry Pi, etc. This one is a RF modules with number of NRF24L01. This is the one. This is the low power one, and the high power is this one, the long one with antenna. Is the NRF24L01 PA/LNA with antenna. Okay, these are transceiver modules, transceiver radios, and power with 3.3 volts only. Be careful. These modules are tolerant to 3.3 volts only to be powered. However, the digital pin out, the digital interface is still 5 volt tolerant. Okay, since this module, the interface, as we can see here, the pin pitch is too narrow, so we cannot directly interface it with the breadboard. Okay, it's wrong to interface directly with the breadboard like this. So I have built this adapter. It's very easy to be built. Here we have a female adapter to be interfaced with the module, and from this side we just have a connection to a male pin, so it will be easy to be interfaced or connect to the breadboard like this. Okay, now let's talk about the pin out for this module and how we can connect it to the Arduino. So usually these two modules are the same pin out. They got the same pin out, so they are interchangeable. Okay, the pin out are shown here. Okay, so this is the pin out. This is the one like this. This is the crystal and the antennas here. So if you hold it like this, you got 8 pin. So the first pin on the top left hand is IRQ for the interrupt, MISO, MOSI, SCK, SCN, SE, VCC, and ground. Okay, let's put it like this. Now, to connect this module to the Arduino, we need to connect the pin. This is the pin for the NRF, and this one for the Arduino. Can be used any Arduino. So the IRQ no need to be connected to any pin. Just leave it free open. CE connect to pin number 9. CSN you can connect it actually to any digital pin, to any digital I/O pin. For here I'll connect to pin number 8. You can connect to any other pin. VCC should be 3.3 volt only. Please be careful of this. Ground to the ground. And for the clock, serial clock to pin number 13. Master out, slave in, pin number 11. Master in, slave out, pin number 12. And I forgot to mention that this interface or this connection is called the Spi Connection. Okay, and also it's good to be mentioned that this module require a bit high power, both of these models, so it's very good practice to add a capacitor to the VCC and to the ground. It's good to add a capacitor here. Okay, capacitor between the VCC and the ground to boost up the power. Okay, so here in the breadboard I already connect the adapter to the Arduino, and only need to be connect to the module to the adapter like this. Okay, and please always make sure that the VCC is connected to 3.3 volts. 5 volt might kill your module. Okay, so with this we have done with the hardware. One more thing to show you. You may build your hardware to be like this. You will embed inside your Arduino chip. Inside there's an Arduino chip, accelerometer, plus the the module, the RF module that used to transmit the data with a battery connection. So this one will be my first node, or my first node that send the data, and this one will be my receiver. So these two module units are going to be talk to each other. So okay, we have done with the hardware. Let's go to do the software coding. Okay guys, so here we will continue with the software for the transmitter and the receiver node. So first, I have already wrote the code to save some time. So first of all, for sure, before we use the RF library, we have to include the library in the Arduino libraries. There are actually two ways to declare or to include the library. First, you can go to Sketch, Include Library, then you go for Manage Libraries. Then you search for NRF or RF24H. Okay, this is the first way. The second way, you can find it online. You search for the RF24 library. Then you can add the library as a zip file. Yeah, I guess for this one, there are a lot of good tutorials online. They will teach you how to add the library to the Arduino libraries. Okay, so after you have included the library, then you have to declare these libraries that required for this code, which are the spi.h, the header file, and RF, and the RF24, and also printf.h. This one we will use it to print out the RF parameters after this. Okay, so after this we need to create an RF24 object and declare also the CE and CSN pin. Here CE pin is number 9, as we said before, and also the CSN is pin number 8. The object name is radio. Okay, then we need to start our serial monitor. Then printf also we need to start it, and also we need to begin the radio that we declared just now. Okay, then we need to open a writing pipe for the transmitter with this address, and make sure that this address should be unique and same as the receiver. Transmitter receiver should be same address. Then we set a channel for the radio. Here I use channel 77. Again, the channel also should be sorry, identical and same to the receiver. Then here in this instruction, we set the power level, okay, to the max, power amplifier to the max. Then we enable a dynamic payload in this instruction. Then since this is a transmitter, so we just stop listening. No need to listen because this one only one-way communication. We're just transmitting the data. And this is the one this is the instruction that we talked about just now. This is used to print out the parameter of the RF. So we make sure that the RF is already correctly configured. And this one just to print transmitter is okay. Okay, in our loop, first we create our message, which is string, hello there or hello world, whatever you wanna send. This is our message. Then we need to set the length of our message or string by using the str.length, okay, plus 1 for the terminator. And then we prepare some buffer because we have to convert the string into array of characters. Okay, so here we convert from the string to array, which is named text. The first, our string actually named as a string, hello there. Now we convert it into an array of character under the name of text with the length of string length. Then after this, we write our data, which is text with the size of text, to the radio. We write this data. Then we print again on the serial and wait for a second. Okay, so now we just upload the code to the target, to our Arduino. As we can see here, we have two Arduinos now. I will use Arduino on COM number 10 for the transmitter and COM number 3 for the receiver. So, okay, COM number 10, Arduino Uno, then we upload. Okay, this shouldn't take a long time. Okay, we are good. So if we open the serial monitor, okay, we can see here, this is the parameter I talked to you just now. This is to see the parameter that's already set and okay. And transmitter okay also. And here we are printing the data, means the transmitter start to transmitting the data. Okay. So now we close this. Now we go to the receiver part. This is the receiver part. And again, we include the libraries, the required libraries, as we said just now. And again, we define the radio with the CECSN pin, exactly the same. And here also we use the serial and printf.begin, exactly same as the transmitter. Then we begin the radio. And here the address or the pipe we're using that I mentioned just now should be same as the transmitter, plus the channel ID, which is 77, also should be matched with the transmitter. And here also some setting. We set just now the power amplifier level to max, enable the payload, the dynamic payload. And as long as this node is a receiver, so we have to start listen to any incoming packet from the transmitter. And again here, just to print out the details of the radio, then we print receiver is okay. In our loop here is a bit simpler than the transmitter. First, we check if the radio is available, means there's a packet available in the radio. Then we make some buffer of text with a 32 byte. It's empty buffer for sure. Then we read the incoming packet into the text, the one we have declared just now, and we print it out on the screen. Then we wait for a small time. Okay, so this one, then we just upload to COM number 3. As we say, this one for our receiver. Okay, uploading done. Then we open the receiver. Here we go, receiver okay, and here we are receiving the data from the transmitter. Okay, very nice. So now if we do some testing that we prove that this is from the transmitter, we disconnect the transmitter now. Now we see that no more packet is coming unless we connect it back again. Then we should see that the packets are coming back again. Yes, here we go. Okay, so until now we learned how to connect the hardware together and also how to design the software for both transmitter and receiver. So thank you very much, and stay tuned for the part 2 where we will connect this NRF to the Raspberry Pi. Thank you very much and see you soon.